Hi and welcome back to a new video. The MSI RTX 5090 Lightning is probably one of the most absurd, most controversial graphics cards that have been launched in the past couple of years. Not so much about its, specific speed or anything, but just, if you receive this, you get this big box. That comes in a big box, that comes in this size of a box. But if you receive it, it also means that you probably spend something between 5,000 to 7,000 euros on a consumer graphics card, which is, even for my standards, quite a lot. And we received this specific one from MIFCOM, which is one of the biggest SIs in Germany, and they planned to use this inside a custom water-cooled system. But as you probably know, the 5090 Lightning comes with an AiO attached to it. So we really thought about, okay, we can just make a custom water cooling block for it, but then it's not so special anymore compared to any other 5090, because you lose this specific feature of having this big screen on it and obviously the design. So we wanted to make a conversion kit, similar as what we did with the RTX 4090 Matrix. So you can convert this from AiO cooling into custom water cooling. We finished this and we want to check this out today. The Seasonic PX 2200 is currently one of the strongest PSUs available, and it comes with two native PCIe 5.1 connectors, which allows to even hook up natively to RTX 5090. That is perfect for any overclocking system or high-end workstations. I'm also currently running this PSU, and so far I'm really satisfied with its quality and performance. The cables are very flexible, there are also cable comps included, and in addition also a 90-degree ATX 24-pin adapter, which also functions as a PSU tester at the same time. The fan is semi-passive, and even at a high load it is still very quiet. Find all information about this PSU in the link in the description. Usually I would start this style of video with just getting stock values of the card, trying to figure out what is the stock performance with this 360 radiator equipped with three 120mm fans. But the thing is that even MIFCOM already had investigated the card in more detail. They took it apart, so we didn't have the stock condition anymore anyway. I'm just left with the remains of the AiO, radiator and pump. And here we have the PCB of the RTX 5090 Lightning. I already cleaned it, and it's still absolutely crazy if you think about it, because it's the same GPU and same memory as on other 5090s. It's only that the PCB is obviously enhanced, and you have two 12-volt high power connectors. And then in combination with the different BIOS, it allows for a higher power target and slightly more performance. And also, if you think about this aspect, the case is not that special. You have this big screen, which is definitely unique for a graphics card, but if you turn it around, you see there is not that much going on. There's just a plastic shell with the screen inside. You have the USB Type-C connector to control the screen in the end, and that's basically it. But we still wanted to obviously keep that, because essentially this is what makes the Lightning a Lightning. Just like the design, the way it looks like, and the big screen, so we wanted to keep that. What I was personally very interested in is how did they make the water block, because that's the thing that sits inside the case, inside the screen, which you typically can't see. I'm sure you saw some of this inside some of the MSI marketing material, and from this side it absolutely looks one of the just ordinary custom water cooling CNC milled blocks. But if you turn it around and if you inspect it from inside, it has absolutely nothing to do with that and is super cost optimized. This is probably as cheap as you could design a block in this kind of assembly. From this side, you just see this big amount of copper. You have the GPU contact patch, memory, VRM, and all the relevant spots. But if we turn it around, has not much to do with a typical custom water cooling block. You can just see the only thing that's missing here is the connection for the pump, like the pump head. But you can probably get an idea of how this works. You can also see the counterpart right here. And it's basically just inlet and outlet on here. And if we take this off, it is one big cover that is on top and a big piece of rubber inside right here. And underneath you have the cold plate. There's not much structure, not much surface area going on. Just in the center where you have the skived structure. Skiving is this process where you just cut into the copper with a blade and then just lift it off, versus the traditional milling. So this is a skived heatsink. Our engineer Joe took over this project. He disassembled everything, came up with the concept, and then he was like, this plate should be investigated, because this is kind of odd and interesting at the same time. If you have a little bit of understanding of materials and you would look at this from a distance, it looks like a nickel coated piece of brass, right? Or like even copper. But then if you hold it in your hands, or like steel, could be steel as well, right? You hold it in your hands and you're like, this is too light. It's the the weight does not match what you would expect. And then we were like, what could this be? So let's take it to the microscope and check it out. First we thought this is just a steel plate, because just the way it looks like, even under the microscope you can see this looks like a brushed steel surface, and we thought we could just repurpose this part and make our own life easier, make the part cheaper in the end, but it just didn't feel right. If you hold it in your hands, it just is too light. So we did a multi-layer analysis of 10 steps, 10 times the laser is basically drilling through the surface, and it starts with nickel, and then at the third attempt it's nickel and phosphorus, which confirms that it's a chemical nickel, and then goes further down and suddenly we're detecting aluminium. This means we have an aluminium plate that has been chemically nickel plated, so electroless nickel plating. And that is especially interesting because you want to transfer parts of the AiO cooled graphics card towards custom water cooling. And the custom water cooling is just a completely different environment, because in your AiO cooled system, a material mix of aluminum and copper is not such a big deal because you have a super controlled environment. You know exactly what kind of materials are used and mixed, and for that you can adapt your coolant. However, in custom water cooling environments, you don't really know all of the components that are being used, and often you also don't know what the customer is using in terms of coolant. That's why the general rule of thumb is to absolutely avoid the material mix of aluminium and copper inside the loop. Now you would argue, but it's nickel plated. The thickness of about 8 to 10 micrometers is usually not sufficient to make sure that it will never corrode. Because in this kind of environment, if there is just the tiniest porosity inside the system or like a crack somewhere, the coolant would go inside and then it would basically corrode the aluminium underneath and the nickel would just delaminate from the surface. And that is something we would absolutely not want to risk in a custom water cooling system, especially with something like a 5090 Lightning. So it was absolutely important for us to check this piece, figure out that it's not steel and that we can't use it for application. And that's why Joe designed this extra stainless steel plate to just replace the aluminum part. And it also already has the fittings attached and also the terminal, which we will use to connect later on the custom water cooling towards the card. And this is also a PVD coated stainless steel plate. You will not be able to see it later, so the design was not the concern, but rather the functionality. So this is just a functional PVD coating for extra corrosion resistance. Same that goes on this stainless steel terminal right here. Now the internals, we have inlet and outlet. We will also reuse the rubber piece. You can also already see where this would make contact. And also this tiny but quite cool touch was added to the inside, even though nobody will ever see it. But it says Lightning RTX 5090 rebuilt to be perfect, and also the alloy that was being used. And rebuilt to be perfect is obviously a connection to this one, where it says built to be perfect, but we optimized this for custom water cooling. It's quite simple to assemble now. We just take the copper coat plate, then we add this piece of rubber that was already included in the original block. We take the big piece of rubber, add this on top, and then add the cover, screw it down, and we're basically done. The only thing I have to do now is just clean all of this once more, so it's perfectly clean, no more residues, and then I can assemble it. Now that everything is assembled, we will put back the entire cooler back into its case. In the traditional water cooling assembly, we would also test a leakage now, which we also did. But Joe definitely had some issues because the tool which we're using, the machine, always reported that there is a leakage, which didn't make any sense. I mean, it's just a very simple geometry, like an O-ring, a lot of pressure with two non-flexible parts, like the big copper and the steel part on top, and didn't make sense. And then Joe suddenly realized that there is this big rubber block inside, and this thing is getting compressed. And what our machine is testing, it's filling it up with a defined pressure, for example, of 0.6 or 1 bar. And then it's checking if there is a pressure loss. And for the machine, it seems to be like a pressure loss, but it's just the rubber that is being compressed and then appears to be like a leakage. So we also tested that. Then Joe disassembled it, took out the rubber, assembled it again, and it was like super tight. And then we put back the rubber and just assumed that everything is fine. But it seems like this kind of assembly with a big rubber block inside makes at least the pressure test a little bit more difficult. Now adding the cover, which then also nicely closes this end with the connecting ports. Next I have to put the actual card back onto the water block, but first I have to prepare this one with new thermal pads. I'm using our Pad Pro with 1mm height, and they are quite soft, so they can easily adapt to different heights if that's needed. All the pads are in place on all the necessary areas, and now I will add a face sheet towards the GPU, even though this might be 1 degree Celsius worse than, let's say, a Duranout Pro, but the longevity is just in the end better, and I think especially for this kind of system that an SI wants to build, longevity is always more important. With these kind of pads, it also doesn't have to be perfect. Like if there's some tiny crack or anything in between, it absolutely does not matter. It's more like a paste, so the pressure and the temperature will then have it reflow anyway, and then it will be fine. Now last step, adding the back plate back on. Now that everything is assembled, we can finally go ahead and test this beautiful card. You can still see all the protective films on the card, like backside and also on front side, but I will not remove these simply because this is not my graphics card. It is supposed to go in a customer PC of MIFCOM, and that's why I will treat it as careful as possible. That's also why I will not switch outside the OC BIOS. I basically don't want to touch anything. I don't want to do any overclocking because it's a very expensive piece of hardware and I do not own it. All I want to do is basic temperature testing, see what kind of temperature range we can get with this kind of modification. Unfortunately, as I said in the beginning, we don't have the stock values of this card because it already came disassembled. But I just checked some reviews, for example, Tech Power Up. They were listing gaming temperatures of around 63, 64 degrees Celsius under load. So we have at least somewhat of a direction how this card could perform in the stock condition, and then we can just see what we can get with the custom water cooling. Now the final moment to test it, and I'm absolutely hyped. I also connected two WireView Pro 2 wired to this card because it carries two 12-volt high power connectors. I also already switched on the water cooling loop powered by my Mora with 3D5 pumps. You can also check stats right here. So we have water temperature of 25.7 degrees Celsius. Yeah, it's quite warm in my room right now. And we have about almost 190 liters per hour of flow. And yeah, even though I have a AC in my room, still it is summer, it is quite warm. So now let's see what happens. I just started Thermite and I'm already impressed by the performance of this thing. If you take into account that the card is currently pulling 800 watts, the temperature is absolutely impressive with about 54 degrees Celsius under load. That is roughly the same temperature as what we see with other custom water cooling solutions with cards pulling about 600 watts. So yeah, the cooling solution with this mod seems to perform pretty well. Also on the two wire views this looks good, not only the single connector but also comparing both connectors with each other, that looks pretty even. There is a slight load difference between the two connectors, but it's not much. And also if you take into account the absolute value, comparing it to a normal 5090, you would see 550 to like 600 watts under load. That is actually easier on the wire view and will make it stay colder with only about 400 watts on each connector. Almost 25 minutes into the test and the temperature is actually improved. You can still see like 53, 54 degrees Celsius on the GPU temperature, but you have to keep in mind that the water temperature also increased. Just cycle through. You can see 31.8 degrees Celsius water temperature now. So the delta just between the water and the GPU is very, very good. And it also makes sense that the phase sheet just improves over time. It's quite interesting, 1 hour of testing is almost over and the temperature increased further. See, it's now switching between 52 and 53 degrees Celsius. And that even though the water temperature increased further. I was also working on another side quest at the same time, and that is an adapter cable for a matrix for vertical mount. So that's also a MIFCOM project. That's why I'm completing this at the same time. Still I have to finish this one, obviously, that I can then switch to the matrix for testing. But with the matrix, you can't use it in vertical mount, and there's also no adapter available. So I asked MIFCOM to send me the small BTF adapter, and I basically just soldered a 12-volt high power cable to it. So like ground, 12 volt, and then added the sense pins on the right. For this one, I just was not quite sure on the sense pins in regard if the cable sense pins are enough. So I could just check where the sense pins from the cable should go to the BTF connector, but I wasn't sure if the BTF connector would require additional things from the motherboard that are now missing. Well, nothing exploded, so that is already something good. Awesome, that's also working. Also with the full load as intended, you can see the 600 watts are successfully being pulled through that cable. So the only thing I still have to do is make this look a bit more beautiful, add some insulation on the cable. But for now, the card passed the 1 hour of testing, and I think the results are pretty impressive if we think about now that we have about 32 degrees Celsius water temperature and about 52 degrees Celsius GPU temperature. That is a delta of 20 degrees Celsius, which I think is a very good result, especially if you consider it's 800 watts. Plus, this block was never built originally for custom water cooling. We transitioned or adapted this from AiO cooling to custom water cooling, and with that, the delta is a very impressive result. Now, the only thing I still have to do is this one. I'm gonna do this on Saturday, so that's gonna be tomorrow for me. And you're watching this on a Sunday, so I hope you have a great Sunday. Enjoy the rest of your day. See you next time. Bye-bye.